Chemical incidents demand life and death decisions, and life-saving decisions demand immediate, complete, precise information. The history of chemical detection is made up of technologies that provide various elements or pieces of this information, but no one device has ever delivered the complete dataset to decision makers in the field. Until the AccuSense chemical recognition system from Seer Technology. The AccuSense's precise detect, identify, and quantify dataset is delivered with instructions for safe response, making it data you can bet your life on. To illustrate data you can bet your life on, this video uses a matrix displaying the detect, identify, quantify, instruct data delivery capabilities of commonly deployed legacy detection technologies, enabling a relative comparison against the data delivery capabilities of AccuSense. A brief explanation of each data element will help make an accurate comparison possible. Detection answers the question, is there something in the air? Identification answers, what is in the air? Quantification answers the question, how much of the identified chemical is in the air? And instruction answers, what response is needed? A more detailed discussion of this comparison is available in the Seer Technology white paper entitled, A New Generation of Chemical Detection Technology. PID. The most commonly deployed legacy technology is photoionization detection, known by its acronym PID, or simply called a PID. Devices using PID technology are common throughout the first responder community and are also used for simple applications in industry. PID technology benefits from being inexpensive and simple to use. It is also quick to detect, and it is sensitive to low concentrations of chemical gases. The limitation of a PID is that it is detect-only technology. It will not identify what chemical it is detecting or provide precise quantification information. In addition, PID devices are prone to false positive readings, so the end user is given limited information, and this information can frequently be in error. Electrochemical sensors. To solve the lack of identification capability problem, PID device engineers will add one or more chemical gas-specific electrochemical sensors to the front end of a PID detector. The electrochemical sensor uses an electrolyte designed to respond to a specific targeted gas. A device that combines a PID detector with 4 different electrochemical sensors is called a 4-gas detector. Electrochemical sensors are cheap and quick, but they are prone to false results and have limited shelf life. Ion mobility spectrometry, or IMS detectors, are common among first responders because they have the capability to identify a class of chemicals such as chemical warfare agents or toxic industrial chemicals. IMS technology measures the time a molecule takes to travel a known path to generate a spectra that can be compared to a library of known spectra signatures. IMS detectors are inexpensive, quick, and simple to use, and they can detect solids as well as gases. However, they are easily confused and prone to false alarms from commonly present environmental confusers, and an IMS does not provide quantification of chemicals detected. Fourier transform infrared spectroscopy, or FTIR. A Fourier transform is a mathematical function that transforms a domain-defining light intensity into a domain-defining chemical spectrum. The source of the light is infrared radiation passed through a captured sample of air. FTIR detectors can identify solids, liquids, and powders in addition to identifying gases. The technology is mechanically simple and is self-calibrating, which makes it simple to operate. An FTIR detector is at its best when it's dealing with high concentrations of chemical gas, which means it struggles with low concentrations. The principle behind FTIR technology assumes that concentrations of gas in the air do not change over time, which is good for lab work but leads to erroneous results in the field where there are many variables to deal with. Gas chromatography mass spectrometry, or GCMS. Portable GCMS detectors were developed to provide the chemical identification and quantification data not available from common field detection technology. The concept of a GCMS is to package laboratory technology for use in the field. In the laboratory, gas chromatograph technology for separating and quantifying chemicals combined with mass spectrometer technology for chemical identification is a successful solution for generating detect, identify, and quantify chemical analysis data. However, because MS technology is recognized as being prone to a phenomenon known as aliasing, this data is subject to false results even in the laboratory environment. Unfortunately, mass spec technology and lab-based procedures do not transition successfully to the field. Mass specs are very delicate, which is fine in the lab, but in the real world, bumps and bangs easily knock them out of calibration, which means extensive service time. GCMS devices are big, heavy, very expensive, and difficult to use. They also require consumable calibration gas, all of which adds to a high total cost of ownership. AccuSense Chemical Recognition System. Dual hyphenated gas chromatography with non-destructive thermal detection. Easy to buy, easy to use, easy to trust describes the design philosophy behind AccuSense. Starting with a blank piece of paper, Seer Technology engineers designed a smart field system that delivers precise detect, identify, and quantify chemical analysis data in a context that instructs at-risk personnel how to respond. In a world of one-dimensional detectors that utilize 11 or 12 data points to verify analysis results, AccuSense is a two-dimensional detector that utilizes 180,000 data points to deliver data you can bet your life on. AccuSense DHGC hardware delivers a hyper-separated signal to Seer ID software, where it is matched to a library of AccuSense high-definition signatures created using neural network algorithms run on a Cray supercomputer. The result is precise analysis data. Precise detect, identify, quantify analysis data is presented to the end user in the context of NIOSH immediately dangerous to life and health standards that instructs the appropriate safety response. AccuSense can be deployed for hazmat point detection or for 24/7 continuous air monitoring industrial hygiene applications. AccuSense changes everything.